Hello and welcome to another Algebra 1 video by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 4, Lesson 7 on the equations of horizontal and vertical lines. Now we have spent a lot of this unit talking about linear functions and equations of lines, all right? But there are two types of lines that I've been kind of avoiding. Lines that are completely horizontal, right, that are parallel with the horizon or the x-axis, and lines that are completely vertical, right, which are parallel to the y-axis. Now both of these are very different from the traditional y equals mx plus b form, all right? And only one of the two actually is even a function, okay? So primarily what we want to work on today is being able to come up with the very simple equations of these lines and also to be able to graph these lines when they're given their equations. Ironically, the equations of vertical and horizontal lines are so simple that students often get them confused. So let's talk about them right away in the first exercise. Horizontal and vertical lines. Horizontal and vertical lines do not fit the typical linear function model, but we can still provide equations from them, or for them, sorry. Never forget that an equation serves to algebraically describe all points on a particular line or curve, right? So like an equation should tell you something about the points that are on the curve, okay? And because horizontal and vertical lines are so simple, their equations are simple as well. So let's get into it. And first, take a look at a horizontal line, all right? So let's do it, the horizontal line case. What I want you to do is I want you to write down two coordinate points that are on this line. I want you to also think about what they share in common, and from that we're going to figure out what the line's equation is. So let's do it, right? We've got these 2 points that are laid out on this line, all right? What are their two coordinates? Well, the one on the left is at the point -2, 4. And the one on the right is at the point 3, 4. Now, when we look at those 2 points, what we should notice immediately is that they share the y-coordinate. Both y-coordinates are equal to 4. Both y-coordinates are equal to 4. Now, it's not just those 2 points, right? If I went to a point over here, that would be -6, 4. If I went to a point over here, that would be 5, 4. If I went to the y-intercept, that would be 0, 4. Every point on that line shares one thing in common, and that's the y-coordinate. And interestingly enough, that's its equation. So the equation of this line, this horizontal line, is just y equals 4. Now you might say to yourself, but wait a second, I thought all equations of lines kind of had both a y and an x in them. Except this equation doesn't have to have x in it because the y-coordinate doesn't depend on what the x is. The x could be anything you want it to be, but the y has to be equal to 4. Okay, what I'd like you to do now in the vertical line case is do exactly the same thing that we just did. Pause the video now and see if you can fill in the answers to these 3 questions. All right, well, let's take a look at the 2 points that are marked on this line. Let's take a look at this one and this one. The one that's kind of lower down, that's the point 2, -1. And the one that's higher up, that's the point 2, 4. What do they share in common? Well, both x's are equal to 2. What's the line's equation? Well, it's x equals 2. Right? That's even stranger, right? That's even weirder, okay? Now, side note, technically, a horizontal line is still a function. Because I could say, hey, what's my output when my input is equal to 7? You know, when x is 7, what's y? 4. When x is -3, what's y? 4. When x is 22, what's y? 4. Okay? This, though, isn't a function. And this one is not even a function. I think I'm going to write that down. I would do it as well if I were you. This is not even a function because that one x value, right, which are the inputs, x equals 2 is the input, has an infinite number of outputs. But what is certainly true along any vertical line is that the x value is always the same And therefore, x equals that number describes all the points that lie on that vertical line, right? Every point that lies on that vertical line shares one thing in common, and that's x equals 2. So let's summarize this. This is pretty darn important, right? Equations for vertical and horizontal lines are so simple that students often get them mixed up or confused for a single point on one of the axes, right? It seems like if I'm like, hey, graph x equals 5, you might think I'm just talking about the point 5, 0, okay? But I'm not. If I say graph x equals 5, I'm saying graph every point where the x coordinate is 5. So horizontal and vertical lines. A horizontal line, right, one that is parallel with the x-axis, always will have an equation that looks like y equals a constant, y equals a number. The vertical line, right, a line that's parallel to the y-axis, will always have an equation like x equals a constant, x equals a number. And again, the key here is the reason for that isn't like some memorization magical thing. It's if you've got a line that's horizontal, the y-coordinate never changes, and therefore y equals that number, whatever that coordinate is, describes every point on that line. On the other hand, if you have a vertical line, what's true about a vertical line is everywhere along that vertical line, the x-coordinate doesn't change. So whatever that x-coordinate is a great way to describe all the points on that line. So let's take a look at a pretty simplistic problem on that. Let's take a look at exercise number 2. Which of the following equations represents a vertical line that passes through the point 5, 3? Well, I mean, just try to picture this, right? We can even draw a little sketch of it, and I always encourage you to do that on a problem like that. This, right? So here I've got my y-axis and my x-axis, and if I went 1, 2, 3, 4, 5, 1, 2, 3, right? Here would be the point 5, -3. And if I drew a vertical line through that point, right, and I wanted to know its equation, the key would be any point along this line would have an x-coordinate of 5, right? If I went right here, this would be the point 5, 0. If I want to couple up this thing, that would be the point 5, 2, 4, 5, 6, 7. If I went up here, that would be the point 5, 7, right? Every one of those points shares one thing in common, and that's x equals 5. So x equals 5 is an equation that describes every point on that line, right? These two lines, because they involve both a y and an x, are what we call slanted lines, right? This one would be one that has kind of a negative slope. This would be one that has a positive slope. And then y equals a number, that would just be a horizontal line, okay? So if an equation involves both x and y to the first power, then it's a slanted line. If it's just x equals a number, it's a vertical line. If it's just y equals a number, it's a horizontal line. So let's get a little practice with these. Again, sometimes in math, one of the trickiest things is the easiest thing. It's important to be able to give the equation for a particular vertical or horizontal line. So exercise number 3, we're going to do that a bunch. Let's take a look. For each of the following, give the equation of the line that's shown or described. All right, so for example, in this first particular problem, we have this vertical line, and what I would suggest doing, especially if you have a graph given, name some points on it. For instance, if I colored in this point and I colored in this point, those 2 points would be 3, 0 and 3, 4. I mean, let me do another one. Let me put a point down here. That would be 3, -5. And then you can just ask yourself, well, what's the same for all of those? For all of those, x is equal to 3. And that is equal to its equation. X is equal to 3. So what I'd like you to do is I'd like you to do that for the remainder of B, C, D, E, and F. Try to come up with the equations of all of those horizontal and vertical lines. Pause the video now. All right, well, let me take a look at letter B. I'm going to do this point thing. I'm going to put a point here, maybe a point here, maybe a point up here. Let's see, those would be the points -4, -2, -4, +3, -4, +6. Looks like every point there has x equals -4. So that's its equation, right? Let's take a look at this one, right? This one, I'm going to just take some random points. Maybe I'll take that, and maybe I'll take this one. Maybe I'll take this one. Whoops, maybe if I can draw that point. So that would be -4, -3. I've got 0, -3. I've got 5, -3. It looks like what's the same on every one of those points is that y is equal to -3. Of course, this method really relies on the fact that you are good at reading off coordinate points, right? Which hopefully, given that you started doing that in 6th grade, by this time you're pretty good at it. All right, let's take a look at letter D. Same thing. I'm going to take this point, maybe this point, and this point. What is that? That's 5, -4, 5, 1, and 5, 5. Looks like they all have an x-coordinate of 5, and therefore that's its line, right? Let's take a look at this one. Maybe I'll go with this point, and this point. Let's see, what would that be? That'd be -2, 4. That almost looks like a -2. That would be 3, 4, and 5, 4. Looks like every one of those points has y equals 4. And let's do one more like this. Maybe take this point, and this point. I would have -5, 3. That's not 3, that's 2. You're talking about reading off points correctly. I have 0, 2, and I have 3, 2. So all of those have y equals 2 as the same. Okay? So when we have a graph on a coordinate grid, it should be pretty easy to come up with the equation of the line, right? It should be simple enough. When they're just described, then it can be a little bit trickier. Let's take a look at G and H. First, G. The equation of a vertical line passing through the point -4, 5. So there's kind of two ways of going about doing letter G. One way is sort of not really understanding exactly what's going on, but just memorizing, hey, look, when I see vertical line, right, I know that's x equals a number. What does x equal? X equals -4. That's one way to do it. Another way to do it is to do a little sketch like we did in that multiple choice problem, where we do 1, 2, 3, 4, 1, 2, 3, 4, 5. We plot the point, we do a sketch of it, and then we think to ourselves, okay, you know, I've got -4, 5, right? This would be -4, 0. I could put one down here, which would be -4, -1, and that should be enough to tell me x equals -4, right? So a little sketch helps. Why don't you try letter H? All right, I want the equation of a line that's parallel to the x-axis and passes through the point 3, 2. Again, you know, to me, it's helpful to draw a little sketch and say, well, I've got the point 1, 2, 3, 1, 2. Let me put my little y and x there. I'm parallel with the x-axis, so I need to be going in the same, you know, direction and the same distance. So this is my point 3, 2. You know, maybe I'd go out here and I'd say, well, that's the point 6, 2. Maybe I'd take this point, that's 0, 2, right? And that means y must equal 2. All right, pretty easy. Now, we do want to make sure we can do one more thing, right? Which is, you know, we want to be able to graph them themselves. Now, horizontal and vertical lines will sometimes be needed to be used when we're trying to enclose a shape in the coordinate plane. And this happens all the time, by the way. You might do it a little bit more next year in geometry than we do it in Algebra 1, but we will see it still on occasion. So let's take a look now at exercise number 4. Sketch the region bounded by the 3 lines whose equations are given below. Label each with its equation. Find the area of the triangular region enclosed by the lines. All right, so what's cool here is we've got 3 lines. One of them's horizontal, one of them's vertical, and one of them's a slanted line, okay? Now, I don't want you to worry about the final two, x equals 4 and y equals -3. I'd like you to take all of the knowledge that we've been building up during this unit and I'd like you to graph this line, right? This is your standard y equals mx plus b. That's a slanted line. It should be no problem. Pause the video now and quickly graph that line. Then we'll talk about the other two. All right, simple enough. Y equals 3/2 x plus 3, right? That's got a y-intercept of 3. It's got a slope of 3/2, so I'm going to go to the right 2 and up 3, right 2, up 3, right? So beautifully sketched. Y equals 3/2 x plus 3. All right, so there's my slanted line. All right, now the other two. Again, there's two ways for you to go about graphing them. One way is to just memorize what kind is vertical, what kind is horizontal. But there's an easier way, right? Literally, when I'm told to graph x equals 4, one thing I could do is just produce some points where x is equal to 4, right? Any points I want. Any points I want as long as x is equal to 4. So for instance, here's 4, 0. Here's 4, 5. Here's 4, -1, right? And if you do that with a few points, it should become pretty obvious that that is a vertical line, right? In theory, if I give you 2 points, there's only one line that can pass through them. So even if you just plotted 2, you'd be good to go. But that's probably enough for us to realize that what we're dealing with here, as poorly as I'm going to draw it, is a vertical line. So that's x equals 4. All right. Likewise, we can do exactly the same thing for an equation like y equals -3. The big difference here is I have to make sure in each case the y coordinate is -3. So I'm going to write down, just like I did before, I'm going to write down some coordinate points, but with -3 in the y position. So maybe now I'll do -4, -3. Maybe I'll do 5, -3. Maybe I'll do 0, -3. So -4, -3. Oh, that point I already actually have. 5, -3. And 0, -3. And again, those 3 points should be plenty enough for you to remember that that is or to realize that that is a horizontal line. So there's our y equals -3. Now the last part of this thing said, label each with its equation and find the area of the triangular region enclosed by the lines. So what's cool is that this actually, right, encloses a triangle. And because it encloses a two-dimensional space, we can figure out what the area is. See if you can pause the video right now and come up with the area of this triangle. All right, well, since it's a right triangle, it shouldn't be too difficult. We just need to know what the base is and what the height is, and then we'll just do area equals 1/2 base times height. Well, we could count boxes, right? We can do it a variety of ways, but it looks like this is 8 units long, right? 1, 2, 3, 4, 5, 6, 7, 8. And here, right, it looks like we've got 9 units and 3 units, so that's going to be 12 units. So we've got a triangle whose base is 8 and whose height is 12. So the area is going to be 1/2 of base times height. You can do this in a variety of ways. Remember, multiplication is commutative, it's associative, it's all sorts of things. So I could choose whichever two of these I want to multiply together first. Lots of students tend to do the 8 times 12 first. That would give you 96, and then finding half of it, which would be 48. I personally like finding half of 8 because it makes my number smaller, and then multiply those together and get 48. We can't really put units on here, but I'll say 48 square units. All right, that's it. Let's wrap this up. All right, horizontal and vertical lines. They actually have an important role in math, as simple as they are. And they are simple because along a horizontal line, right, the y coordinate never changes. And therefore, the equation of a horizontal line is just y equals whatever that coordinate is. And likewise, along a vertical line, right, the x coordinate never changes. And therefore, the equation of a vertical line is x equals whatever that unchanging number is. All right, these things are so simple that students oftentimes, in my experience, will sort of have the idea one day, and then the next day it can be like just totally gone. What do you mean graph the line x equals 5? X equals 5 isn't a line, it's a solution to an equation. But x equals 5 or 9 or 11 or whatever is a line because it's just telling you, hey, graph all the points that have this as their x-coordinate. All right, we will use equations of horizontal and vertical lines a little bit here and there in the next few lessons and throughout the course. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.